Hello students, in this video we're going to learn about vectors. So again you will require the worksheet on vectors uh, to to understand this video better. But before we start solving the problems, I would like to go through, revise certain basics, right? And I'm going to assume that you know certain things. I'm not going to explain why it is so, because this is for the grade 12 students, right? So let us start. Now you all know that the vector is nothing but, what is the difference between a scalar and a vector? Okay, a scalar only has a magnitude, whereas a vector has both magnitude and direction, right? Vector has a direction also along with the magnitude, right? That you know. Now if you take a point A in a two-dimensional plane, let's say for example point A with coordinates, let's say 1 comma 2, right? And if I take the point O, the origin, and if I join this OA vector, okay, from O to A, then this vector can be written as OA vector equal to like this, like a matrix 1 and 2, or I can also write it as I cap plus 2j cap, right, where I cap is a unit vector in the direction of x, and j cap is a unit vector in the direction of positive y-axis, I cap in the positive x-axis. Okay, now so how do you find the magnitude of this vector? Very simple. Magnitude of OA vector equals square root of 1 square plus 2 square, which is nothing but square root of 5, which means the length of this line segment is not, this line segment OA is nothing but root 5. So I'm not going to explain why, how come we can get the magnitude of this vector using by squaring the components. These are called components, scalar components. By squaring the components, adding them and taking the square root. Okay, I'm not going to go into that. I have taught you this much earlier, right? So this is how you find the magnitude of a vector. Okay, now suppose you have a point A, let's say 1 comma 2, and the point B with coordinates, let's say 3 comma 5. Then how do you find AB vector? How do you find AB vector? Again, quite simple. AB vector is nothing but OB minus OA. So which means 3, 5 minus 1, 2. So which is nothing but 2 and 3, right? So if I want to find the magnitude of AB, again, which is quite simple, you square 2 and 3, add them, and then take the root of that. So I'll get square root of 13. So the magnitude of AB is square root of 13. Okay. Now I have seen many students make this mistake. They confuse between this, for example, let's say 1 comma 3 comma 5, a point in the space, and 1, 3 and 5. They try to use it, they feel that both of them are actually same. Both of them are completely different students. If you take these are the coordinates of a point A, then these two are not equal, in fact. Okay, this represents the coordinates of a point A in the space. Now this is actually a vector. Okay, vector of that point, the position vector of this point from the origin, right? So please don't confuse both. So they are completely different. Okay, now you know that two vectors are parallel if they act on parallel lines. For example, if you take this vector and this vector, they're actually parallel to each other. As you can see, they have different magnitudes, but still they are parallel to each other. You can also have, now these two are parallel to each other and they have the same direction. Now look at these two vectors. Now these two vectors are also parallel, but they have completely opposite directions. Yeah, in this case the angle between the vectors will be 0 degrees, and in this case the angle between the vectors will be 180 degrees. Yeah, angle between the vectors. Okay, now how can we identify parallel vectors using components? Now if two vectors are parallel, then each vector will be a multiple of another vector. So A vector will be KB vector. So what I'm trying to say here is, suppose let's say if A vector is 1 and 3 and B vector is, let's say, 3 and 9. So definitely A vector is parallel to B vector. As you can see, I can write this 3 comma 9, 3, I'm sorry, not 3 comma 9, 3 and 9 as 3 times 1 and 3. So which is nothing but 3 times A vector, right? So definitely I can, these two vectors are actually parallel vectors. And since A vector equal to 3B, B vector equal to 3A vector. So what it means is the magnitude of B will be 3 times the magnitude of A. Suppose if magnitude here in this case you can see that the magnitude of A is nothing but square root of 10. So definitely magnitude of B will be 3 times square root of 10, right? And this value of K represents, since it is positive, it means that both B and A have the same direction, right? So that means the angle between them is actually 0. The angle between the vectors 1 3 and 3 9 is actually 0. Yeah. So let us look at two vectors which have parallel vectors which have completely opposite directions. For example, if I take let's say A vector as -2 and 3, and if I take B vector as, let's say, 4 and -6, as you can see, B vector can be written as -2 times -2 and 3, which is nothing but -2 times A vector. So B vector is -2 times A vector. So which means the magnitude of B will be 2 times the magnitude of A vector, and the angle between them, the angle between B and A will be 180 degrees, because if A is like this, then B will be like this, double of A. So if this is A vector, then this will be B vector. So angle between them will be 180 degrees, right? Good. So if two vectors are parallel, definitely you can see that the scalar components of the vectors will be proportional. For example, let's say 2, 1 and 5, and let's say 10, 5 and 25. You can see that both the vectors are actually parallel to each other, right? Because the components are proportional. Like for example, 10 by 2 and 5 by 1 and 25 by 5, all of them are actually equal, right? So these two vectors are parallel vectors. But if you consider 3, 1, 2 and 6, 2, -4, right, they are definitely not parallel to each other. As you can see, the components are not proportional. 6 by 3 is 2, 2 by 1 is 2, but that is not equal to -4 by 2, isn't it? So definitely these two vectors are not parallel. Okay, now how do you find the dot product between two vectors, students? For example, if I want to find, let's say, dot product of 1, 2 and -4, dot 3, 5 and 2. How do you find it? Very simple. You just multiply the corresponding scalar components and add them. So 1 into 3 plus 2 into 5 plus -4 into 2. So you get 13 minus 8 equal to 5. Again, I'm not going to explain what do you mean by a dot product and how do we get this, in fact. Why are we multiplying the corresponding scalar components and adding it? I'm not going to explain, right? That I'll do it in a different video. But this is how you find the dot product, right? Now, suppose if two vectors are perpendicular, that means if the angle between them is 90 degree, then you will notice that the dot product will definitely be 0. Let me give an example. Let us consider the vector A vector equal to 1 and -2, and let us consider B vector as -3 and no, let me consider another vector. Let me consider let's say -4 and -2. Okay, now if you find the dot product between them, so it will be if we find a dot b, it will be 1 into minus 4 plus minus 2 into minus 2. So which will be minus 4 plus 4 equal to 0. So definitely, which means if these two are non-zero vectors, isn't it? This non-zero means the magnitude will not be 0. So if you find the dot product of two non-zero vectors, and if you get 0 as the answer, then definitely those two vectors will be perpendicular to each other. So the dot product of two perpendicular vectors will always be 0. And I'm really sorry, I'm not going to explain again like how we get it. Why is it that the dot product will be 0 and what it means and what is the relevance of a dot product. I'm not going to explain in this video, that is for a different video, but you all know already, but since I'm just revising this concept. So the dot product of two perpendicular vectors will always be 0, right? Okay, now let us consider this problem, students. Suppose if A vector is 3 minus 1p and B vector is 2, 5, 1. Given that A vector is perpendicular to B vector, then find the value of P. Suppose if this is the question. Now, since they have given that both these vectors are perpendicular to each other, definitely the dot product will be 0. So A dot B will be equal to 0. So you'll get 3 into 2 plus minus 1 into 5 plus p into 1 will definitely be equal to 0, which means 6 minus 5 plus p equal to 0, which means p equal to minus 1. So the value of p is minus 1. So use the property that the dot product of two perpendicular vectors will always be 0, right? Okay. Now I'm going to revise how to find the angle between two vectors. Suppose let's say if A vector is 3 minus 1 4 and B vector is 2 1 6. Okay, so how do you find the angle between two vectors? Very simple. The formula is cos theta equal to A vector dot B vector divided by magnitude of A multiplied with magnitude of B. So A dot B will be 3 into 2 plus minus 1 into 1 plus 4 into 6 divided by, the magnitude of A will be square root of 9 plus 1 plus 16. So basically I am squaring 3, 1, minus 1 and 4 and then add them and take it under the square root. And again magnitude of this vector, so which square of 2 which is 4, square of 1 which is 1, square of 6 which is 36. So basically you will get 6 plus 24 minus 1. So 29 divided by square root of 26 multiplied with square root of 41. This is cos theta. So theta equal to cos inverse of this value. So you can use the calculator to find the answer. So this is how you find the angle between two vectors. Okay, now let us consider this vector, students. Suppose let's say A vector is 2 and minus 5. Okay, suppose if they ask you to find a unit vector in the direction of A vector. Now you can see here A vector, the magnitude of A vector is nothing but square root of 4 plus 25, which is square root of 29. So the magnitude of A, this vector, is square root of 29. Now if they ask you to find a vector in the same direction as A, but it should be a unit vector also, that means the magnitude is 1. You know that the unit vector, a vector whose magnitude is 1, is called as a unit vector. So how do you find it? Very simple. The formula is 1 divided by magnitude of A into A. So the required answer is 1 by square root of 29 into 2 1 minus 5, right? This is the required vector. This is the unit vector in the direction of A vector. Now if you want to check whether the magnitude of B is 1, you can definitely find out. So this can be written as 2 by root 29 minus 5 by root 29, right? So I can find magnitude of B, which is nothing but square root of 4 by 29 plus, if I square this, I'll get 4 by 29, and then if I square this, I'll get 25 by 29. So which is nothing but square root of 29 by 29, which is equal to 1. So definitely this is a unit vector. Now since b vector equals 1 by root 29 into a vector, right? B vector equal to this. So basically a multiple of a vector. So b vector is a positive multiple of a vector. So as I mentioned earlier, then definitely b and a will be parallel to each other, and not just parallel, they will have exactly same direction. The angle between them will be 0, right? Now let us consider another vector. Suppose let's say a vector equals 5 1 minus 3, and if the question is find another vector in the same direction as a but magnitude of let's say 5. So I want another vector, let's say b vector, whose magnitude is 5, but it should have the same direction as a. So again, very simple. The formula is b vector is 5 times the unit vector along a. That means 1 by magnitude of a into a vector, right? That is how you find it. So magnitude of a vector is nothing but square root of 25 plus 9. So square root of 34. So the answer is, the required vector is 5 times 1 by root 34 times 5 minus 3. So the answer is 5 by root 34 times minus 5 and minus 3. So this is a vector whose magnitude will be 5 and in the same direction as a vector. If you want to cross check, you can find the magnitude of this. So this will become 25 by root 34 minus 15 by root 34. So you can try to find the magnitude of this. Okay, so anyhow, let me find it. So b vector, magnitude of b vector is, so squaring this, I'll get 625 by 34 plus, and squaring this, I will get 225 by 34. So basically I'll get 850, I'm sorry, 850 by 34, which is nothing but square root of 25, which is nothing but 5. Yeah, so it's proved. So this is the vector. Fine. So next we are going to see how to find the vector equation of a straight line, students. Okay, suppose let's say I give you a point A. Okay, I give you a point A. Now how many lines can you actually draw which passes through A? So definitely there are infinite lines, isn't it? You can draw infinite lines which passes through A. For example, you can draw this line, or you can take this line, this line, or this line, or this line. So there are infinite lines which actually pass through the point A. Okay, let me erase it. But what if I give you a point, let's say this is point A, and also I give you a vector. Now, how many lines can you actually draw which pass through the point A and also parallel to this given vector? Right? There can be only one line, isn't it, student? There can be, you can draw only one line which passes through the point A and also parallel to this vector. So what I'll do is, I'm going to derive the equation of this line. I'm going to derive the equation of this line. So I'm going to take the A as x1 comma y1. Okay, and I'm going to take this vector as, let's say, b vector. I'm going to take this as b1, b2. Okay, now how do I find the equation of this line? Okay, what I'll do is I'll take the origin O, and which is nothing but 0 comma 0. The coordinates are 0 comma 0. I'll join this with A. So this is OA vector. Okay, and I'll take another point P, any point on this line whose coordinates are x and y. So I'm not, now x1 y1 or actually specific points, given point. X and Y can be any point on the line. So I'll join O with P. Okay. Now I'm going to take this vector as R vector, and I'm going to take this vector as A vector. Right? So A vector and R vector. So A vector is nothing but x1, y1 in matrix form. So if I want to write R vector in matrix form, it will be R vector equal to x and y. Okay. Okay. Now how do you find the equation of this line? So you know that AP vector is parallel to B vector, isn't it? Because this line is parallel to B vector. So AP lies on the vector AP vector lies on that line. So AP vector is parallel to B vector. And I taught you earlier that if two vectors are parallel, then they will be each vector will be a multiple of another vector. So I can write AP vector as TB vector. Right? I can write AP vector as TB vector. Now we know that AB means OB minus OA, isn't it? For example, AB is OB minus OA. If it is CD, CD is OD minus OC. Now if it is, let's say, PQ, PQ is OQ minus OP. Same way, AP vector will be OP minus OA equal to TP. But we have taken OP vector as R vector, isn't it? R vector minus, I have taken OA vector as A vector. So R vector minus A vector equal to TB vector. So finally, R vector equal to A vector plus TB vector. So this is the equation of this line, right? R vector equal to A vector plus TB vector. You can also write this as, I'll write it in the top left hand corner. I'll write it here. So I can also write it as R vector means xy equal to A vector, which is x1, y1 plus t times B vector, so b1, b2. So you can also write like this. So this is called as the vector equation of a straight line. Okay. So to find the vector equation of a straight line, you require a given point and you also require a parallel vector. So you require a parallel vector and you require a given point on the line. Now you may wonder, what is the role of this? What is the role of this t? What is the role of this scalar t? I'm going to explain with the example. We'll look at that next. Let me explain what is the role of this t with an example. Okay, let us consider this problem, students. Find the equation of a straight line passing through the point 2, minus 3 and parallel to the vector 4 and 5. Okay, so that means if you try to draw a rough diagram, the line will look like this. So this is the line. So this is the point 2, minus 3, and this is the vector, parallel vector, which is 4 and 5. Okay, so the answer is very simple. The equation of line is R vector equal to A vector plus some T B vector. So which is nothing but A vector is nothing but 2 minus 3. Plus that means A vector is the position vector of this point. Okay, plus T times this is the B vector. So 4 and 5. So R vector equal to 2 minus 3 plus T times 4, 5. Right. So this is the equation of a vector equation of a straight line passing through the point 2, minus 3 and parallel to the vector 4 and 5. Yeah, this is how you find it. Okay, let me give you another example. So let's say there is a line which passes through the point 3, 2 and which is parallel to the vector. Let's say the vector is minus 1, 6. So the equation of this straight line is nothing but, I'll take this point as A. So nothing but R vector. So let me write it here. Let me write it down. So R vector equal to 3 to A vector plus T times B vector, which is minus 1, 6. Right. So you may wonder, what is this R vector? What is this R vector? Very simple. Take the origin. and take any point on this line. Join O and P, and that is, this vector is our vector. So then what about this vector? What is this vector? 3 and 2. Very simple. Join O and A. This vector is 3 and 2. Right? And this is the parallel vector. So actually this will always give the direction for the straight line. Okay, minus 1 and 6. Okay. Now let us come to what is the use of this t. Now t is actually a real number. Okay, so t can take any value. In fact, it has infinite values, right? Now what is the role of t? By giving different values for t, you actually get different points on this line. For example, let's say if you put t as 1, what will I get? I'll get r vector equal to 3, 2 plus t is 1, so minus 1, 6. So I'll get 2 and 8. So basically 2 comma 8 will actually be a point on this line. Okay. Now suppose if you put t as 0, if you put t as 0, what will you get, students? You will get r vector equal to, if you put t as 0, you will get only 3 and 2. So basically which is nothing but a vector. So when t is 0, the point P will be here. P and A, point A will be coincide. I mean, both points will coincide. So the t actually, the different values of t gives you different points on this straight line. Okay, so t can take any value. T can be any real number. Okay, now I'm going to teach you how to convert equation of a line which is in vector form to an equation of a line in Cartesian form. It's very, very simple. Please listen carefully. Let's say r vector equal to 3, 2 plus some t into 5 minus 1. Okay, let's say I want to convert this. This is in vector form. Okay, sometimes we also write r vector as x and y, vector x and y. So we can also write like this. Okay, now what happens is x, y equals, I can combine these two and write it as 3 plus 5t and 2 minus t, isn't it? Now you can, this means x equal to 3 plus 5t and y equals 2 minus t. X is equal to this and y equal to this, which means t is x minus 3 by 5 and here t is 2 minus y. So this is also t and this is also t, so I can equate them. X minus 3 by 5 equals 2 minus y. So if you cross multiply, you will get x minus 3 equals 10 minus 5y. So you will get x plus 5y equal to 13. Right? It's not clear. So x plus 5y equal to 13. So this is Cartesian form. Cartesian. And this is vector form. This is vector form. Fine. Let me give you one more example, students. Let's say first, let's say xy equal to minus 1, 3 plus s times s into, not 5, this is not 5, this is s, 2 and 5. Okay, so I can write this as x equals minus 1 plus 2s and y equals 3 plus 5s. So s is nothing but x plus 1 by 2 and here s is nothing but y minus 3 by 5. So I can equate them both. X plus 1 by 2 equals y minus 3 by 5. So cross multiply, you'll get 5x plus 5 equals 2y minus 6. So I get 5x minus 2y equal to minus 11. So this is the Cartesian form and this is the vector form. Cartesian form and a vector form. Right? Very, very simple. Okay, fine. Now let us have a look at how to find the point of intersection of two lines in which are in vector form. Okay, let us consider two lines. Let's say first line is r vector equals 3 2 plus t times, let's say 5 and 1. Okay, and let the second vector be r vector equal to, you have, let's say 4 9 plus s times, say you get minus 1 and 1. Okay, so let's say these are the two lines. Okay, let me replace this 1 with 6. Okay, now if they give you these two lines and if they ask you to find the point of intersection, so first thing you need to do is, and one thing you noticed is, student, this is t and this is s. So they are two different variables. So definitely when you have two different lines, you can't have the same variable. You can't have t here and t here also. Okay, it has to be t and s, or some other a and b, anything like that. Okay, so to find the point of intersection, the first thing you need to do is you need to equate both the equations. That means 3 2 plus t times 5 1 equals 4 9 plus s times minus 1 6. So this is the first thing you should do. Okay, the second thing is, now you get 3 plus 5t 2 plus t, isn't it, students? And on the right hand side you get 4 minus s and then 9 plus 6s. You get like this. Now you need to equate the corresponding components. So you get 3 plus 5t equals 4 minus s, which means 5t plus s equal to 1. So I can take this as equation 1. Now if you equate this and this, the second component, so 2 plus t equal to 9 plus 6s, which means t minus 6s equal to 7. This is equation 2. Okay, so I got two equations now. This is equation number 1 in t and s. This is equation number 2 in t and s. So how do I do it? Very simple. You already know how to find simultaneous system of equations. So what I'll do is let's say I keep one as it is. That means 5t plus s equal to 1. I'll multiply the second equation by, actually, okay, let me write it here. I'll keep the first one as it is. That means 5t plus s equal to 1. Now I'll multiply the second equation by 5. So I get 5t minus 30s equal to 35. Right? So when I subtract, you get 31s equal to minus 34. So s equals minus 34 by 31. Okay, so the value of s is this. Now you need to substitute this value here in 4 minus s and 9 plus 6s. So that will give you 2 points. So that is the point of intersection. I know that the value of s doesn't look good, right? I mean minus 34 by 31 like that. So let me give you another example where you can get like a proper value. Let's say s is equal to 1 or 3 like that. Okay, let us take another example. Okay, now let us consider these two equations, students. So I need to find the point of intersection of these two lines. So first thing is, as I mentioned earlier, you equate it. So 2 1 plus t times minus 1 7 equals minus 3 2 plus s times 2 1 3. And the second thing is, you will get two equations. That means 2 minus t 1 plus 7t equal to minus 3 plus 2s 2 plus 3s. So again equate the corresponding components. You will get 2 minus t equal to minus 3 plus 2s, which gives you 2s plus t equal to 5, equation 1. Okay, now equate this and this now. So 1 plus 7t equals 2 plus 3s, which means 7t minus 3s equal to 1, the equation 2. Okay, now what I'll do is I will multiply the first equation by 7. So first equation by 7 gives you 7t plus 14s equals 35. I'll keep the second equation as it is, which is 7t minus 3s equal to 1. Okay. Now when I subtract, I'll get 17s equal to 34. So s equal to 2. So I get the value of s is 2. Now substitute this 2 here. So you'll get minus 3 plus 2 into 2, which is 1. And then you'll get 2 plus 3 into 2, which is 8. Therefore, 1, 8 is the point of intersection of this line and this line. This line. Okay, so 1, 8 is the point of intersection. So this is how you find it. Okay. Now the last problem of this video. So what if you take two lines in 3 dimensions? In that case, how to find the equation, the point of intersection? Let us consider one example. Okay, let us consider this problem, students. There are two lines R1 and R2. They intersect at the point P. They intersect at the point P. So the question is, find the coordinates of P. So the first thing is you need to equate both. So you write it as 2, 3 minus 1 plus s into 5 minus 3, 2 equals 9, 2, 2 plus t times minus 3, 5, 1. Now you'll get 3 equations, students. The first equation will be 2 plus 5s. I hope you know how you got it. 2 plus 5s equals 9 plus 6t, right? The right hand side. So which implies 5s minus 6t equal to 7. I'll take it as equation 1. Okay. Now let us look at the second one. That is this minus 3, that's 3 minus 3 and all those things. So you get, let me use a different color now. Let me use the blue color. So 3 minus 3s equals 2 plus 5t. So if I combine s and t, so I'll get minus 3s plus 5t, minus 5t, right? So you get minus 3s minus 5t equal to minus 1. So this is equation 2. Okay. Now let us take the last part, that is minus 1 and 2. So you get minus 1 plus 2s equals 2 plus 1t. So 2 plus t, which implies 2s minus t equal to 3. So equation 3. So I have 3 equations now. You can solve any 2 of them to get either s or t. So what I'll do is I'll take, maybe let us take first and third. Yeah, I'll take first and third. So I'll keep the first one as it is, which is 5s minus 6t equal to 7. Okay. Now what I'll do is the third equation I'll multiply by 6. Okay, 6. So I'll get 12s minus 6t equal to 18. Okay, if I multiply by third equation by 6, I get this. So now when I subtract, I'll get minus 7s equal to minus 11. There is a small error, students. I'm sorry. I think I copied the question incorrectly. So this is minus 1. Sorry, this is minus 1. Okay, so that means the third equation. So you have to be very, very careful. Even if you know the method, this is how you can actually lose marks. So you have to be very careful when you copy the question. So here you have -1. So that means the third equation will be 2 minus t. So it will be not 2 plus t, it will be 2 minus t. So 2 minus t. So you'll get 2s plus t equal to 3. So in this case it will be plus 60. Fine. There is one more thing. I think this is incorrect, right? This is 9 minus 3t, right? So I put 9 plus 3t again, which is incorrect. So let me correct it. So let me write it here. So this whole thing will go. So I'll get 9 minus 3t. So which will give me 5s plus 3t equal to 7. That is equation 1, right? So I hope I've got it right now. So that means this, let me erase this part. So let me solve equation 1 and 3 now. So equation 1, I'll keep it as it is. So 5s plus 3t equal to 7. Now equation 3, I'll multiply by 3. I'll get 6s plus 3t equal to 9. Okay, so if I subtract, I'll get minus s equal to minus 2. So s equal to 2, right? Now I'll substitute the value of s here. So 2 plus 5s, so 2 plus 5 into 2 is 12, and 3 minus 3s, so 3 minus, so I'll substitute it here. 3 minus 3 into 2 is minus 4, and then I'll substitute it here. So minus 1 plus 2 into 2 is 3. So the point of intersection is 12 minus 4 and 3. Sorry, another error here. I don't know what happened. Making a lot of mistakes. So 12 minus 3. Sorry. So this is 12 minus 3 and 3. Fine. Well. So the answer is the point of intersection is the point coordinates of P is 12 minus 3 and 3. So fine. I think there are 3 mistakes, right? I mean, it also shows that the math teachers can also be human. So you have to be very, very careful, students. So you may know the process, you may know how to do it, but the careless errors can actually become very costly errors. So let's say if it is a 7-mark question, you may actually lose almost like 3 to 4 marks. You may get only 3 marks. So please be very careful. And most often or not, then you may wonder, how did I find out that I made a mistake? So if you recall, I got yes earlier as some not an integer. I got some other number, isn't it? Something like 34 by 11 or something like that. Then suddenly I had a doubt. So normally you don't get, it's not like you can't get, you will definitely get, but normally you will always get the values of s and t as integers, like 1, -1, 3, or -2, or 1.5, like that. I mean, 1.5 is not an integer, but at least it's better than 34 by 11, isn't it? So you'll get numbers like that. So whenever you don't get it like this, for example, if you get SS, just one example, let's say 28 by 15, or TS 31 by 16, something like that, then maybe there is something wrong in the question, or maybe you copied the question incorrectly, or maybe while simplifying it you made a mistake. So please take care of it, and that is one way of checking whether what you've done is correct or wrong. Okay, and fine. I mentioned that is the last video, but I think there is one more problem that I need to do. With that, we'll wind off, students. So the last problem for this video. Okay, fine. This is the last sum, students. So let us consider these two lines, R1 and R2. So suppose if they ask you to find the angle between these two lines. Okay, we know the formula for angle between two vectors. But if they ask you to find the angle between two lines, you can use the same formula. Now this is the vector that gives the direction for the first line, and this is the vector that gives direction for the second line, isn't it? So I'll take this vector 5 minus 1 as a vector, which is, so I'll take it as 5 minus 1, and I'll take the second vector 3 2 as, I'll name it as b vector, so 3 2. So the same formula, cos theta equals a dot b divided by magnitude of a into magnitude of b. So you get a dot b is nothing but the dot products of 5 into 3 plus minus 1 into 2 divided by magnitude of a is square root of 25 plus 1. I hope how you got it. So square this and add it and take the square root, multiply it with magnitude of this, so square root of 9 plus 4. So you'll get 15 minus 2 divided by square root of 26 into square root of 13. So basically you'll get 13 by 13 root 2, right? If you multiply this, you'll get 13 root 2. So you'll get 1 upon root 2. So if cos theta is 1 upon root 2, then it's very simple. Theta is nothing but 45 degrees, right? So the angle between these two lines is actually 45 degrees, students. Okay, fine, students. I hope you're able to recollect all the concepts. So from in the next few videos, we'll start solving the vector problems in the worksheet, right? Fine. Thanks for watching this video, students.